seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11.
Shadow. 4 forward, drift into the right a little. 30 seconds forward, drift. Contact light. Okay, engine stop.
Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue.
We're going to be busy for a minute.
Armstrong is on the moon. Neil Armstrong, 38-year-old American, standing on the surface of the moon. On this July 20th, 1969.
It's one small step for man, one giant leap for mankind.
On July 20th, 1969 at 10:56:15 p.m. Eastern Daylight Savings Time, as Commander Armstrong ventured onto the surface of the moon to be the first human being to ever do so, the sounds and images you just experienced were witnessed by over 500 million people worldwide. Neil Armstrong's one small step was the crowning accomplishment of an endeavor that really began centuries ago. Many Inspired Steps tells the story of that endeavor from the earliest recorded thoughts and dreams on man's ability to fly, through man's conquest of the air in the 20th century, and the conquest of space, which culminated with the triumph of Apollo 11, and much more. While Neil Armstrong was granted the chance to take that crowning one small step, he was provided that opportunity through the countless steps taken by pioneers throughout the centuries, by all those involved in space programs, and especially by the men and women of the Apollo 11 program, which at its peak numbered over 400,000 employees. Using mostly public domain images from NASA, Many Inspired Steps was conceived, created, designed, and copyrighted in 2014 by Dr. Thomas A. Lesser, formerly senior lecturer at the American Museum Hayden Planetarium, in preparation for the celebration of the 50th anniversary of the Apollo 11 moon landing. Although countless individual contributions over time went into the achievement of this unprecedented goal, limitations of both time and space allow the retelling of this journey to touch only on the highest points along the way. Many Inspired Steps is a museum exhibition consisting of 47 24 by 36-inch display panels. Exhibit creator, Dr. Lesser, graciously donated digital copies of his creation, free of charge, through the exhibition's distributor, Audio-Visual Imagineering Incorporated, to qualified not-for-profit organizations. These organizations are then permitted to print out the panels for exhibition at their chosen locations. The current video, created jointly by A Time for Science Nature and Science Learning Center and Esprit Productions LLC, by permission of Dr. Lesser and AVI Incorporated, is an adaptation of the static exhibit, Many Inspired Steps. Keeping as true to Dr. Lesser's work as possible, this version of the exhibit is intended for presentations by A Time for Science, both at its Chi-Yu Lee Planetarium and Digital Theater, and as part of its outreach programs to schools and other venues in eastern North Carolina, where limited accommodations preclude a display of the full complement of museum exhibit panels. Beliefs, opinions, and thoughts about the moon and imagings about human flight have been around in all cultures throughout time, from man's observation of birds, bees, bats, and butterflies. In 500 BC, Anaxagoras opined that the moon is not a god, but a great rock, and the sun was a hot rock. In Greek mythology, as told by Yakov Pierre-Gouy in his 17th century work, Daedalus, in order to escape from the island of Crete, built a set of wings for himself and one for his son, Icarus. However, ignoring his father's warning, Icarus flew too close to the sun. His wings melted, and he crashed to the ground. Chinese legend tells the tale of Wan Hu, who had 47 rockets tied to his chair, and when 47 servants lit them all simultaneously, Wan Hu disappeared in a cloud of smoke. Decidedly more successful was the first untethered manned balloon flight built by Joseph Michel and Jacques-Étienne Montgolfier. It made its ascent on November 21, 1783 in Paris, France. And the rocket's red glare of the Star-Spangled Banner came from the rockets being fired by the British at Fort McHenry in Baltimore Harbor the night of September 13th through the 14th, 1814, during the War of 1812. In 1902, Simon Newcomb, the director of the U.S. Naval Observatory, stated that flight by machines heavier than air is impractical and insignificant, if not utterly impossible. Only 1 year later, on December 17, 1903, in Kitty Hawk, North Carolina, brothers Orville and Wilbur Wright proved him wrong with the flight of one such heavier-than-air machine that was not only powered but whose flight was under control by the machine's operator. Their airplane's first flight was 120 feet long, lasted 12 seconds, and flew at a speed of only 6.8 miles per hour. After the success of the Wright brothers, aeronautical science expanded rapidly, and advancements in the technology of flight accelerated. The French De Pierre Dusson, a 1912 racing monoplane, was the first aircraft to exceed 100 miles per hour in level flight. The initial flight of the first operational jet fighter, the German Messerschmitt Me-262, took place in 1942, and the plane became operational in 1944. On October 14, 1947, at a speed of 807.2 miles per hour, Chuck Yeager in the Bell X-1 became the first man to break the sound barrier in level flight, that is, to fly faster than the speed of sound. The first commercially successful jet passenger airliner, the Boeing 707, was introduced into service in 1958. Intrigued by the thought of it, the futurist and science fiction author Jules Verne once declared that we shall one day travel to the moon. Having published extensively on the theory of rocketry, the Russian-Soviet scientist Konstantin Tsiolkovsky proposed the use of liquid fuels for rockets as early as 1903. The German scientist Hermann Oberth built his first model rocket at age 14. Among his many achievements as an accomplished scientist, he independently conceived the multi-stage rocket, launched a liquid fuel rocket in 1917, published his book Ways to Spaceflight in 1923, worked for Nazi Germany during World War II, including work on the V-2 missile. After the war, one of his assistants, Wernher von Braun, would become the father of the American space program. As described by the German Federal Archives, the V-2, pictured in this test launch by the Allies after World War II in 1945, was 46 feet long and could carry a 1,650-pound warhead 225 miles. It has been estimated that the Germans launched over 3,000 of these rockets during the war that brought about unmistakable destruction, especially in London. The most notable name in American rocketry is, of course, Robert H. Goddard. In 1926, he launched the first liquid-fueled rocket, which flew for only 2.5 seconds, climbed to 41 feet, and landed 184 feet away. The two inventions derived from Goddard's research that were most critical to landing a man on the moon were the multi-stage rocket, which he developed in 1914, and the liquid fuel rocket. On October 4, 1957, October 5th in Russia, the Soviet Union successfully launched the first artificial Earth satellite, Sputnik 1, into orbit. Sputnik 1 was 23 inches in diameter and weighed 184 pounds. It orbited the Earth until January 4, 1958, completing 1,440 orbits. It could be seen from Earth using binoculars, and its radio signal could be heard by anyone with a shortwave radio. In the United States' first attempt to orbit a satellite on December 6, 1957, the Vanguard TV-3 rocket exploded on the launch pad. (1958) turned out to be a more successful year with the launch of Explorer 1, the first American artificial Earth satellite, on top of Juno 1 rocket. A full-size model of Explorer 1, shown here, is being held high, from left to right, by William Hayward Pickering, the director of the Jet Propulsion Laboratory in Pasadena, Dr. James Van Allen, and Wernher von Braun. The Explorer 1, mounted on the Juno 1 rocket, weighed 30.8 pounds. Sputnik 1 was 184 pounds. Instruments aboard Explorer 1 led to Dr. James Van Allen's discovery of the radiation belts around Earth that now bear his name. Also notable for 1958 was the creation of NASA, the National Aeronautics and Space Administration. 1959 was a busy year for space research. The Soviet spacecraft Luna 1, with a model shown here, performed the first lunar flyby, was the first craft to leave Earth orbit, and was the first craft to orbit the Sun. The American Pioneer 4 passed within 37,300 miles of the Moon, but unfortunately, its camera failed. The Soviet Luna 2 was the first craft to impact on the Moon, and the Soviet Luna 3 was the first craft to photograph the far side of the Moon. As reported on the front page of the Huntsville, Alabama Times on April 12, 1961, Yuri Gagarin became the first human to travel in space. Yuri's Vostok 1 capsule is on display at the RKK Energia Museum outside of Moscow. Astronaut Alan Shepard peers into the Mercury space capsule, Freedom 7, and prepares for launch. Seated securely into Freedom 7 atop a Redstone rocket, on May 5, 1961, Alan was launched into space to become the first American to travel in space. Alan made a 15-minute suborbital flight, and when he splashed down just north of the Bahamas in the North Atlantic, he was recovered by the crew of the USS Lake Champlain, CVS-39. The moon landing goal was set when, before a joint session of Congress on May 25, 1961, President John F. Kennedy declared,
"I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth."
To put his challenge into perspective, the president went on to say,
"No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish."
In order to accomplish a moon landing, the Apollo spacecraft would have to travel a total of some 953,700 miles and achieve a maximum speed of 24,200 miles an hour. However, at the time of this speech, America had sent only one astronaut into space just 3 weeks earlier. Alan Shepard's suborbital 15-minute Mercury flight had traveled only 302 miles from its launch pad, reached a maximum altitude of only 116.5 miles, and a maximum speed of only 5,134 miles per hour. Enos, the chimpanzee, was not launched into space aboard the Mercury Atlas IV until November 29 of 1961. He completed 2 orbits of the Earth before safely returning. And consider that in all of 1961, America launched 41 space rockets, of which only 23 were successful. It was said that even some of NASA employees doubted that Kennedy's goal could be accomplished. On February 20, 1962, 10 months after the Soviets placed Yuri Gagarin in orbit, John Glenn climbed into his Mercury capsule, Friendship 7, and was launched into space atop an Atlas ICBM, that is, an intercontinental ballistic missile. Thus, John Glenn became the first American to orbit the Earth, completing 3 orbits in 4 hours, 55 minutes, 23 seconds. If astronauts were going to land on the Moon, American scientists needed to know a great deal more than they knew in the early 1960s about the Moon's surface, about living and working in space, and about manipulating spacecraft. Consequently, 1962 and 1963 were spent with moon surface investigations and longer spaceflight experiences. Ranger 7 was an American spacecraft designed to take close-up photographs of the Moon prior to impacting on the Moon's surface and photographed the Guernica crater from a distance of 830 miles, just 8.5 minutes before impact. The last picture by Ranger 7, taken about 1,600 feet above the Moon, revealed features as small as 15 inches across. The photo is incomplete as Ranger 7 impacted the Moon while transmitting the image.
Impact.
Soviet cosmonaut Valentina Tereshkova became the first woman in space when she spent 3 days orbiting the Earth aboard Vostok 6, June 16th through the 19th, 1963. In 1965, cosmonaut Alexei Leonov became the first person to walk in space when he floated outside the Voskhod 2 spacecraft for about 20 minutes. Fewer than 3 months later, astronaut Edward H. White II became the first American to walk in space, spending 36 minutes outside the Gemini 4 spacecraft. White was attached to the spacecraft by a 25-foot umbilical line and a 23-foot tether line, both wrapped in gold tape to form one cord. White's helmet was gold-plated to protect him from the unfiltered rays of the sun. Since the plan for landing on the moon called for one craft to remain in lunar orbit while another craft landed on the surface and then returned, being able to rendezvous and dock, or reattach, in space was critical. In October 1965, the Gemini 6 mission had to be scrubbed, or postponed. NASA then decided to launch Gemini 7 in December, and while Gemini 7 was in Earth orbit, Gemini 6, officially the Gemini 6A mission, was launched. The two Gemini spacecraft rendezvoused but did not dock on December 15, 1965. March 16, 1966, Gemini 8 astronauts Neil Armstrong and David Scott performed the first docking in space when they docked with an Agena target rocket. Before humans could walk on the moon, scientists needed to know if a spacecraft could land on the moon. One hypothesis, prevalent at the time, held that the moon's surface was covered with a thick layer of dust, and that a spacecraft would just sink as if it were in quicksand. The Soviet Luna 9 became the first spacecraft to land on the moon on February 3, 1966, and it didn't sink. The American Surveyor 1 landed on the moon on June 2, 1966. Here we see Surveyor 1's shadow on the moon's surface, and this is a moon rock photographed by Surveyor 1. Getting to the moon had been a big question a couple decades prior, but as quoted in the Huntsville, Alabama Times in May of 1950, Dr. von Braun says rocket flight's possible to the moon. Considered one of the fathers of modern space exploration, landing a man on the moon, and especially development of the Saturn V rocket, were two of Wernher von Braun's projects. He served as the first director of NASA's Marshall Space Flight Center in Huntsville, Alabama, from 1960 to 1970, seen here with the Saturn V in the background. The 363-foot-tall Saturn V is shown here in comparison to the 305-foot-tall Statue of Liberty. The first two American space programs used military rockets to send men into space. The Mercury program used the Redstone for suborbital flights and the Atlas for orbital flights. The Gemini program used the Titan II. To send men to the moon, a much more powerful rocket was needed, a rocket specifically designed for the moon mission. That rocket was the Saturn V. Overall, the Saturn V is 363 feet tall and weighs more than 6 million pounds. Stage 1 can develop as much as 7.5 million pounds of thrust. Stage 2, 1 million pounds thrust. And Stage 3, 200,000 pounds thrust. That's 8.7 million pounds thrust overall. The stages and sections of the Saturn V were built off-site and assembled in the world's tallest single-story building, the Vehicle Assembly Building, or VAB, which was approximately 350 feet tall. The size of the building can be judged by the Saturn V rocket, which is 363 feet tall, plus the height of the transporter. The first launch of the Saturn V was on November 9, 1967, and for years remained the only launch vehicle able to transport human beings beyond low Earth orbit. Capsule sizes seen here are same-scale images showing the relative sizes of the three spacecrafts. And this image shows the rocket sizes and the relative sizes of the three rockets employed for their launches. Tragedy struck twice in 1967. When on January 27, while training for the first Apollo mission, scheduled for February, astronauts, left to right, Virgil Gus Grissom, Edward White, and Roger Chaffee were killed in a fire aboard Apollo 204, which was later redesignated as Apollo 1 in honor of these men. Here we see the exterior and interior of the Apollo command module, revealing the extent of the fire. Later that year, on April 24th, during the first Russian Soyuz mission, cosmonaut Vladimir Komarov was killed when his craft crashed at several hundred miles per hour. Komarov was the first person to die during a spaceflight. In preparation for future landings, the Apollo 8 mission, as seen in this diagram, was to orbit the Moon. The spacecraft was launched atop a Saturn V rocket on December 21, 1968, and entered lunar orbit on December 23. In all, Apollo 8 made 10 orbits around the Moon. The Apollo 8 crew, James A. Lovell Jr., William A. Anders, and Frank Borman, were the first humans to see the far side of the Moon and photographed it, capturing one image being this 250-mile diameter crater. They were also the first humans to see the entire Earth sphere in one view. This is a photograph of the whole Earth taken by a human and remains iconic as the photograph of the first human view of the Earth rising over the Moon. The Apollo 11 crew was selected to be Neil A. Armstrong, commander, Michael Collins, command module pilot, and Edwin Buzz Aldrin Jr., lunar module pilot. The 15 major steps for overall mission plan were set and were as follows: launch, leave Earth's orbit, command module turns to dock with lunar module, pulls away, orbits the Moon, and then the lunar module separates from the command module and lands on the Moon so that astronauts can explore the Moon. After the exploration is complete, the lunar module lifts off from the Moon, docks with the command module in lunar orbit, jettisons the lunar module, leaves lunar orbit, separates from the service module, and then splashes down in the ocean using parachutes, where the astronauts are picked up by a helicopter and taken to a ship. And then the specific training began, which included training in the Gulf of Mexico for getting out of the command module after splashdown. Here, Buzz Aldrin trains under weightless conditions aboard a KC-135 aircraft, dubbed the Vomit Comet. And here, Mike Collins and Director of Flight Crew Operations, Deke Slayton, are seen after flight training in a T-38 jet aircraft. Here's Neil Armstrong practicing his sample collecting skills. Here we see Apollo 11 atop a Saturn V as it leaves the vehicle assembly building as part of final preparations. And here they are, Apollo 11 and Saturn V, seen on the crawler transporter at Launch Complex 39A. Finally, after much preparation, Armstrong, Collins, and Aldrin walk into the astronaut transfer van, which transports them to the launch pad.
40 seconds away from the Apollo 11 liftoff. All the second stage tanks now pressurized. 35 seconds and counting. We are still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6.
On July 16, 1969, the journey began. There was plenty of excitement as Saturn V cleared the launch towers, surrounded by a thick cloud of condensation as it made its way through the dense lower atmosphere. Then, after a final thrust, first stage separation is executed. Apollo 11, while still attached to the Saturn V's third stage, entered Earth orbit, and 12 minutes later, after completing 1.5 orbits of the Earth, the third stage fires and sends the spacecraft toward the Moon, referred to as the translunar injection. About 30 minutes later, the command and service module, together as one unit, separate from the third stage, turn around, dock with the lunar module, and remove it from the third stage. Having docked together, the spacecraft spends the next 3 days traveling from the Earth to the Moon, a distance roughly that of 10 circumnavigations of the Earth. During the transit, when Apollo 11 was approximately 158,000 miles from Earth and traveling at a speed of almost 3,000 miles per hour, Buzz Aldrin is seen here illustrating to the television audience how to make a sandwich under zero-gravity conditions. And here, Neil Armstrong is seen during the trip from the Earth to the Moon. Upon reaching the Moon, they then enter the Moon's orbit, with Michael Collins seated in the command module. Apollo 11's intended landing site was in the Mare Tranquillitatis, which is Latin for the Sea of Tranquility. This is the lunar module Eagle, as seen from the command module after separation, with Neil Armstrong and Buzz Aldrin aboard as it's being prepared for descent to the moon. In turn, as seen from the lunar module, the Eagle, this is the Apollo command module, Columbia, with Michael Collins aboard orbiting the moon. From orbit, the larger crater, crater Schmidt, is clearly visible in the Sea of Tranquility. The moon's surface is seen here as the Eagle makes its descent. And finally, the Eagle touches down, shown here, in an artist's rendering of the Eagle landing on the moon. Then on July 20th, 1969 at 4:17:40 p.m. Eastern Daylight Savings Time, the world heard Neil Armstrong proclaim,
Tranquility Base here. The Eagle has landed.
The next evening, broadcast live by a television camera mounted on the side of the lunar module, Neil Armstrong climbed down the ladder and placed the first human footprint on the moon. Thus, on July 20th, 1969, at 10:56:15 p.m. Eastern Daylight Savings Time, nearly 500 million viewers heard Neil Armstrong speak those famous words.
That's one small step for man, one giant leap for mankind.
Later on, Buzz Aldrin exited the lunar module to join Neil in the planned exploration and experiments. We see Buzz Aldrin coming down the ladder, looking down at his boot on the moon. One of Buzz's boot prints left behind in the moon dust. Here is the lunar module, where some science experiments have been set up, as seen from the Tranquility Base. Seen here from the lunar module, Neil Armstrong and Buzz Aldrin plant an American flag. Since there is no air and thus no wind on the moon, a regular flag would have just hung down against the pole, as Buzz Aldrin saluted it. Buzz Aldrin is seen here saluting the American flag. So although the flag was an off-the-shelf 3x5-foot nylon flag, a hem was sewn in the top so that a pole could be inserted, making the flag look like it was waving. To commemorate Apollo 11 mission, a stainless steel plaque measuring 9 inches by 7 5/8 inches, shown here in a reproduction, was attached to the ladder of the lunar module. Here's a close-up of the plaque taken before the mission took place, and here as it appeared on the lunar module after the Eagle had landed. While Neil and Buzz went about their work of exploration and running experiments, Mission Control in Houston, Texas, kept close watch on all of their activities. Buzz Aldrin is seen here unloading the early Apollo surface experiments package from the lunar module. Here, Buzz is deploying the solar wind composition experiment, which consisted of an aluminum foil sheet that was exposed to the sun for 77 minutes. This allowed for solar wind particles to embed themselves in the foil, which on return to Earth were studied in the NASA laboratories. Buzz is next to the passive seismic experiments package, which detected moonquakes and provided information about the internal structure of the moon. The laser-ranging retroreflector seen here reflects an incoming light and beams it back in the direction from which it comes. By using laser beams aimed through large telescopes on Earth and then observing the reflected beam, a measurement to within an accuracy of 1 inch can be made of the distance between the Earth and the Moon. This is the only Apollo experiment that's still returning data from the Moon. Neil Armstrong is seen here inside the lunar module after the final moonwalk of Apollo 11. After about 21.5 hours on the Moon, the astronauts lifted off from the lunar surface in the ascent stage of the lunar module, with the liftoff as seen in this artist's rendering. This is an artist rendering, seen of the lunar module ascent stage, docked with the command and service module in lunar orbit. After Neil Armstrong and Buzz Aldrin rejoin Michael Collins in the command module, the ascent stage is jettisoned to eventually crash into the Moon. Here the command module fires its rocket to leave lunar orbit to start the return trip to Earth. Now this is an actual video of the Apollo 11 ascent stage as seen from the command module, and the Apollo 11 command and service module as seen from the ascent stage prior to docking. This image is an artist's depiction of the return module with astronauts on board, in its voyage back to Earth aboard the command module. After separation from the service module, the command module's heat shield protects the crew as it re-enters through the Earth's atmosphere. Near touchdown, the parachutes open to slow the craft down for a landing in the water. Here the command module floats in the Pacific Ocean about 15 miles from the recovery ship, the USS Hornet. The Apollo astronauts are in the raft along with a Navy diver. The Apollo 11 astronauts arrived on the USS Hornet wearing biological isolation garments to protect Earth from any disease that might have been brought back from the Moon. Astronauts, from left to right, Armstrong, Collins, and Aldrin, are greeted by President Richard M. Nixon while still in the mobile quarantine facility, a converted Airstream trailer. Notice the astronauts are wearing their Hornet Plus 3 buttons, signifying the crew of the USS Hornet who were joined by the 3 astronauts. The Apollo 11 astronauts collected about 48 pounds of material, 50 rocks, fine-grained lunar soil, and 2 core tubes that included material from up to 5 inches below the Moon's surface. The first lunar material from Apollo 11 are shown here, arriving at the Lunar Receiving Laboratory of the Manned Spacecraft Center in Houston, Texas. The 2 main types of rocks collected were basalts, which are rocks solidified from molten lava. This sample is about 4 inches across and weighs less than half a pound. And breccias, which are rocks that are composed of fragments of older rocks. This sample is about 3 inches across and also weighs less than half a pound. 3 new minerals were discovered in the rock samples collected by the astronauts: tranquilitite, peroxferrite, and armalcolite, which was named after the 3 astronauts, Armstrong, Aldrin, and Collins. None of the material contained any water, nor did it provide any evidence of life. As can be imagined, thousands of Apollo 11 souvenirs began to appear everywhere, just a sampling of which were drink cups and coffee mugs, pennants of all type, United States Postal System issues of Apollo 11 stamp, first day of issue cover, Apollo 11 stamp cover with Apollo 8 stamp, postmarked on July 16, 1969, the day of launch and bearing Neil Armstrong's signature. All manner of buttons and pins, Apollo 11 stories on Super 8 black and white films, which were then the counterpart of today's DVDs. Pencil sharpeners, and even Wedgwood came out with memorial plate. Of course, celebrations and parades sprang up throughout the country. Shown here is the ticker tape parade on Broadway in New York City. From left to right, Edwin E. Aldrin Jr., Michael Collins, and Neil A. Armstrong. The Apollo program continued lunar studies for another 3 more years beyond 1969, with Apollo 12 making the trip in November of 1967 and landing within 600 feet of the Surveyor 3 probe that landed on the Moon in 1967. Shown here is one of the astronauts deploying science instruments taken from the side of the lunar module. Because of an explosion in the service module, there was no moon landing for Apollo 13, which was launched in April of 1970. However, the successful, improvised instrument repair developed by mission control scientists and engineers thrust this story to movie prominence. Shown here is the happy Apollo 13 crew on recovery from splashdown. Shown here is the crescent Earth above the lunar module of Apollo 14, which was launched in January of 1971, and an astronaut uses his hand to shield his eyes from the sun's glare. The lunar rover, aboard Apollo 15, launched in July 1971 and allowed the astronauts to explore much more of the Moon's surface. Here, the ascent stage of the lunar module is returning to the command module after lifting off from the Moon. Seen here racing on the moon is the lunar rover on the Apollo 16 mission launched in April of 1972, and an astronaut is caught in this photo in mid-leap by the American flag and the lunar module. One of the Apollo 17 astronauts is seen aside a large lunar boulder. Seen here is Eugene Gene Cernan in the lunar module in his spacesuit covered with moon dust. He was the last man to walk on the moon. And years later, after the close of NASA's lunar program, Gene is quoted as saying, "I'm quite disappointed that I'm still the last man on the moon." Looking back over a half a century, a true sense of the space race between the U.S. and Russia cannot be achieved without pointing out the many failures. Because the American space program was, for the most part, uncensored, it seemed at the time as if the Soviets were making great strides, while as seen in this failure of the Little Joe 4 launch vehicle in 1961, that American rockets, more often than not, blew up on the launch pad. The American Ranger program is a good example. From today's perspective, the mission of the Ranger program seems simple enough. Namely, launch the probe, as the probe approaches the moon, have it take photographs which would be transmitted back to Earth, then allow the probe to crash into the moon, that is, not even land. Ranger 1, August 23, 1961, launch failure. Ranger 2, November 18, 1961, launch failure. Ranger 3, launched January 26, 1962, missed moon. Ranger 4, launched April 23, 1962, spacecraft failed. Ranger 5, launched October 18, 1962, spacecraft failed. Ranger 6, launched January 30, 1964, lunar impact, but cameras failed. Ranger 7, launched July 28, 1964, successful. In 1973, after completion of the Apollo program, NASA's attention turned to Skylab. The first American laboratory in space was launched on the last Saturn V rocket. Each of the 3 missions on Skylab had 3 crew members, and all 3 were conducted during 1973. In 1979, Skylab re-entered the Earth's atmosphere, and while most of it burnt up before reaching the Earth, some parts survived re-entry and were later found. Following Skylab came the Space Shuttle and the International Space Station. Many notable firsts and extensive technical advances were achieved over the course of these programs. Sally Ride became the first American woman in space in 1983. Guion Bluford became the first African American in space in 1983. Bruce McCandless II in 1984 became the first human to make an untethered spacewalk. The Space Shuttle program lasted from 1981 through 2011. The Space Shuttle was designed to be a partially reusable spacecraft. The shuttle was launched with additional external rockets and a fuel tank which were jettisoned. Shown here in orbit with its cargo bay doors open, many of the shuttle missions were devoted to work on the International Space Station, though the repairs to the Hubble Space Telescope were notable exceptions. The shuttles then landed without power like gliders and were then refurbished for reuse. Finally, a true appreciation of the risks and dangers involved in space travel, even today, can only be sensed when we remember those who gave their lives in the service of mankind's insatiable quest for knowledge and discovery. In addition to the death of the Apollo 1 prime crew, Virgil Gus Grissom, Edward White, and Roger Chaffee, who were killed in a fire during training in their command module, sadly, the Soviet Union also lost 4 cosmonauts during the race to the moon. They were Vladimir Komarov, when in 1967 the parachutes on his Soyuz 1 spacecraft failed on his landing descent, and Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov, when in 1971 their Soyuz 11 capsule depressurized during preparations for re-entry into the Earth's atmosphere. Since that era, the astronauts aboard the Space Shuttle Challenger mission STS-51L, Greg Jarvis, Christina McAuliffe, Ronald McNair, Elizan Onizuka, Judith Resnick, Michael J. Smith, and Dick Scobie were lost in an explosion 73 seconds after launch. And the astronauts aboard the Space Shuttle Columbia mission STS-107, Rick D. Husband, William McCool, Michael P. Anderson, David M. Brown, Kalpana Chawla, Laurel M. Clark, and Ilan Ramon. NASA's beginnings have been filled with trials and tribulations of learning how to fly real fast, how to venture beyond our atmosphere into the space around our planet and beyond. What we've learned so far is just the beginning of what we've yet to discover as we look to the stars and forge forward. We're already preparing to return to the moon and to Mars after that. Will we find life on other planets? Will you be part of the journey and follow in the footsteps of those who paved the way before you? Where will the future take us after these many inspired steps?